All right, the last video in practice 3 is 3.6, and we're look overview of skill-related fitness. Again, we're going to be looking at this more specifically throughout the rest of the semester. So we will look at speed, agility, and reaction time, sometimes also known as quickness. Really, we want to develop this through the SAID principle, right? That's the specific adaptations to imposed demands. And we've kind of talked about this already. We want to go about 3 times a week to develop these things, because these are going to be a higher intensity. So they're going to be near max. So the intervals we go are going to be pretty short, 3 to 30 seconds, and we typically want a full recovery, or at least, staying in that target heart rate zone. With that said, these adaptations will take place really over that 4-week training session. For some of these, that get a little bit more technique involved. So the more technique we can develop, typically the more proficient we become. So that's where the extended duration comes from. Beyond that 4 to 6 week range is mastering technique, rather than kind of general fitness for the other ones above. So we look at certain studies. Again, this is scientific conditioning of athletes. So throughout the semester, I'm going to ask you to find some of these studies yourself and to investigate what they're saying and think about what the applications are. But this study done in 2011 by Ross and Leverett looked at the long-term metabolic and skeletal muscle adaptations to short sprint training. So what they found was that after the intervention, the experiment, is that athletes increased their speed, agility, reaction time, and they kind of went a little bit further and said, well, why did this occur? How did this occur? So some of these things were neurological adaptations that the neuromuscular innervation, the recruitment of motor neurons was enhanced. So there was more nerves that innervated the muscle, and that's the communication and the synchronization of those nerves increased. So that's one of the specific adaptations of undergoing speed, agility, reaction time training is the muscles are more receptive, responsive to that neuromuscular communication. Another adaptation undergoing this is the hormonal adaptations. So we look at cortisol, and that is it basically how we call it a stress hormone, but it can have some benefits too. Part of that is a catabolic effect, but also it's almost like a stimulant effect as well. So trained muscles that undergo speed, agility, reaction time can decrease that cortisol response time, so it becomes available sooner, and it increases the cortical sensitivity. So another cortical hormone is the adrenaline, norepinephrine. So again, those are kind of stimulant, or actually they can increase strength as well. Other things are the metabolic pathways. We'll talk about that later, but it's basically the how our body uses energy, and these are the kind of the quick, powerful energy pathways: the phosphocreatine recycling and the breakdown of glycogen. So those become more efficient when we undergo speed, agility, reaction time training as well. In addition to those 3 things, we get the muscular adaptations too, that the type 2A muscle fibers are targeted. So they're going to kind of act more like those type 2 muscle fibers. If you get like the cross section of the muscle, there's more hypertrophy, right? So they respond more to these things. And that sarcoplasmic reticulum, right? That's the fluid that bathes your muscles, that is high in different ions and whatnot, is that there's an increase in calcium ions. And what that calcium ions do is they unlock the action potential between the actin and myosin, basically so your muscles contract quicker and more forcefully because of some of those benefits. So those are some of the specific adaptations to those imposed demands of speed, agility, reaction time training. We'll talk more about measurement of conditioning of athletes later on in the semester, but these would be some agility tests we can do to assess agility reaction time. So again, I'll provide links to these in Canvas, so don't get overwhelmed by those videos. But again, think about what are your specific needs for your sport, and how can some of these be utilized to enhance training or to assess your athlete's progress. We can also look at balance and coordination, right? How our muscles do those kind of fine motor skills, right? One of the things we have is proprioception. So in your joints, in your tendons and ligaments, and in the belly muscles, you have different muscle spindles. So these are special neuromuscular organs that when they receive pressure or when they're stretched, they communicate to the brain. So typically, if you've ever walked on the sidewalk and then your ankle rolls, it will snap back kind of automatically. And that's part of the Golgi tendon apparatus, and the muscle spindles are kind of involuntary taking over to protect the muscle. So we can enhance that communication, which they can also improve balance and coordination. We also have the vestibular system in the inner ear. So as we age, right, there's fluid in these little spindles here, and that fluid can become thicker. And so that's why we can become maybe dizzy faster. We maybe lose some of our balance as we age. Unless, right, we practice that, we keep that up. So if you've ever looked at like figure skaters or dancers who can spin and then go right into a jump, they have enhanced that neuromuscular communication, and they have a very trained, specifically adapted vestibular system. Whereas maybe you've seen people between innings at a baseball game, they put their head on a bat, they spin around a few times, and they try to run to do something, and they fall over. Right? If someone has a very highly trained vestibular system, like a dancer or figure skater, they could probably do that with less challenge. And another thing we can look at is movement economy. Again, this is where the specificity in training and technique take over. So this gets later in the mesocycles, in the heart of the competitive season. Once we've established the base fitness, then we can start to refine skill more. We can iron out some of those nuances to maximize performance. So depending on the sport, again, it's really hard to do a specific to sports, so that's what I'd like you to look at a little bit more for each sport. But for running in particular, pretty much every sport requires some type of running. We want to be linear, right? We don't want to be zigzagging or bouncing all around. the more deviant off that course, the more energy is being expended and less of it's going forward. So we want to look to be linear. Again, we can talk about that centered. We kind of look at the pelvis, the abdominal area. What's that doing during activity? So sometimes we think of that as quiet movement. If you ever look at a proficient sprinter, this link I have here is Michael Johnson kind of critiquing Usain Bolt and what he's doing well as a sprinter, and even some other movement economy he can refine. But if you look at any sprinter, is they have a very quiet head and upper body. Their arms and legs are moving violently, but their head and their torso is really moving almost on a quiet plane. Other things we can look at, right, is rotational force. We can look at leg turnover and different things like that. So that's again a really broad overview. We're going to be looking more specifically at some of these things. And I encourage you to look at this video about Michael Johnson looking at Usain Bolt. So again, we want to put all these pieces together in your next portfolio and think about what that means for your athletes.